Evangelist at Retail Me Not. You can ask me what that means later. For now, I'm going to talk about the BeagleBone Black, which is a robotics platform. And when I mention robotics, a lot of web developers kind of look at me like, oh, I can't do web robotics, or I can't do robotics because I don't know C or C++ or BASIC or whatever languages that are necessary for robotics. And actually, I don't either. I don't do C, I don't do C++, I don't really do low-level languages. I did them in college to pass the classes and get out. And then I became a fully fledged JavaScript addict. And you don't need to know these languages either in order to do robotics. So it's my personal mission. I've been running around trying to do this in Texas and now around the nation to convince web developers that they too can do this. This is an awesome, fun way to work with JavaScript. Just a quick disclaimer, I love all node bots. I'm speaking about BeagleBone today, but I am a fan of any platform that runs JavaScript, so definitely that's my common reaction when I see a new way to do robotics with JavaScript. So. But back to the point, what is the BeagleBone Black? It is a platform, a lot of the parts are from Texas Instruments, and Texas Instruments is heavily involved, but it is an open source piece of hardware. So it's $45 for the standard little credit card sized platform. 1 gigahertz ARM processor is basically basic specs for, one of my coworkers phrased it really well. It's basically the computer that sat on your desk 3 years ago. So, except it has GPIO pins, that's where it starts to differentiate itself. What's different between the BeagleBone and the Raspberry Pi is a question that I get regularly. One of the major benefits I've found is you can SSH directly through the serial port. You don't need a second screen and setting everything up with a Wi-Fi module before you can SSH into the BeagleBone. It's built directly into the platform. So you don't need a second screen to start working with the BeagleBone. And for me especially, I don't like carrying a second screen around. So definitely a handy platform. There are analog output pins on the BeagleBone. Raspberry Pi does not currently have those. So definitely helpful if you want to do like LEDs with fading or without having to use a logic changer. And then there are accessible PRU microcontrollers. What those are used for is very timing sensitive pieces of code because they're not interruptible. So you can run pieces of code that are like, you absolutely need to make sure that it runs. I haven't actually experimented with them yet, but there are 2 of them available on the BeagleBone. The other reason I really like the BeagleBone Black is that JS is a first-class citizen. You don't need to install Node because it's already there. It's running Cloud 9 on port 3000, and you can directly edit your JS on the platform without having to SSH in. However, the downside of that is it is very unstable. I think it's the platform because I downloaded the same version of Cloud 9 to my MacBook, worked fine. Trying to work with it on the BeagleBone has been a little bit shaky. So there are several libraries available for using the BeagleBone Black with JavaScript. The traditional one is BoneScript that's developed by the actual hardware developers. And it does remind me a lot of actually programming like an Arduino style procedural language. It's not a lot of evented. You kind of have to build that in yourself. I usually just wrap pubs up around it. The other one is BeagleBone.io, which was released recently, and the creator is in the audience, and that's pretty cool. And it's a Johnny 5 wrapper, basically, for BeagleBone. So if you've ever used Johnny 5 and NodeBots and you like that syntax, I really like that syntax, especially with the events built in, you can use BeagleBone.io to wrap that syntax around your BeagleBone. So it is pretty new, so there's a lot of features that are still being worked on, but what's there is really nice and really handy. There are a couple downsides. So it's really difficult to get a hold of a BeagleBone board, or especially more than one. Adafruit usually has them in stock once every 3 weeks, and they last about 3 hours, and they're gone. And you're allowed to order one at a time. I believe this is because someone decided to put an actual BeagleBoard in a production product and just started ordering all of them as they came out, so they would just vanish. So they're trying to discourage that kind of ordering by allowing one at a time, but they still sell out really quickly. The community support for the electronics half of things and for the non-JS parts of BeagleBone is not as prolific as Raspberry Pi, as Arduino. So that can be kind of an issue, but I'll discuss how we can get around that in a little bit. And like I mentioned, the JS support for BeagleBone is much stronger compared to Raspberry Pi, compared to really, besides Johnny 5 with Arduino, there's really not that level of support yet for that there is with BeagleBone, but Johnny 5 totally still has us beat. This is the second statement I get from web developers when I talk about robotics, and this statement especially is it's frustrating to me because I'll give you a lesson of everything I know about electronics. That's it, right there. That is all I know about electronics, is that when I'm wiring up an input, there's 3 wires, input, ground, and power. If there's a 4th pin, I'm Googling frantically to figure out how to wire this up. Same with output. There's ground, power, and an output pin. And sometimes there's resistors in there. And yeah, I know how a resistor works, but don't ask me to identify one based on the color coding. I have a little index card for that in my toolkit. And that's it. That is literally all I know about electronics. And that's all you need to know about electronics in order to get started with Arduino, with BeagleBone, with any of these platforms, really. The reason we can get away with this is a project called Fritzing. It's an open source piece of software. It's very CAD-like. You move elements around on the screen and you draw diagrams much like the one on the screen. And it has most of the parts. It has a BeagleBone graphic for you. It has most of the graphics you'd ever need to diagram out wiring. And they also have a really handy search feature on their website where you can look up, okay, I need an RGB LED. I need this type of sensor. And it'll show you all the fritzing diagrams other users have made for that particular piece. And if you look at the electronics lesson, basically if I want to move this diagram onto the BeagleBone, I just need to find my power pin, my ground pin, and my output pin. And then I've adapted that wiring diagram to the BeagleBone. Also, Johnny 5 repo has a ridiculously nice amount of documentation around wiring, around coding, around handling odd situations with robotics. So I definitely fall back to that repo very, very often in order to figure out what I'm doing with the BeagleBone, even though it is Arduino based. So I'm going to do a couple demos, and that GIF represents how smoothly everything's going to go, because how often do live demos fail? So when you plug in the BeagleBone, you'll go into your Finder, and you'll see the device kind of pop up here, and you'll see a start.htm, and that takes you here. And this should turn green immediately. Sometimes the drivers can be a little bit picky, but it gives you the downloads for all the drivers, and then it basically gives you an introduction to the board and how to navigate around, and it tells you to launch this IP, which it maps to the actual BeagleBone. So this is being served live from this guy right here. So I mentioned Cloud9 being served directly off the board. There's a link right there. It does take a little bit. Ta-da! So we now have a live editor for the code that's sitting on the BeagleBone. You can also run the code from here. My demonstration doesn't do that, but you can run the code from Cloud9, and as stable as it gets, you can edit the code. It's really nice to not have to SSH in. But what we're going to do is we're going to, sorry. Okay. So it's nice that it has this dedicated IP for us to SSH into. And okay, so I'm in. Oh, my apologies. Better? Perfect. So what this particular bot does is oh wait, I have a plan for this. Hold on. Come on. Okay. So now all of you can see great pictures of my cat too. Fantastic. So what I've got here, this is a temperature sensor right there. And this is an RGB LED. So what I've got is a piece of code that maps the temperature between 60 degrees Fahrenheit and, right there, 60 degrees Fahrenheit to 110 degrees Fahrenheit to red to green to blue on the RGB LED. So I'm going to run that code real quick. I'm super good at naming files. So, let me switch back to my camera. As you can see, we've now got the light. It's kind of a greenish blue because it's nice and cool in here. And it updates every 10 seconds because like I mentioned with the Bone script, there's not a lot of evented code in there, so I'm just having, I'll show the code actually, it's a much easier way to explain it. So I have the function set LED and I have the function map temp to RGB to basically convert the reading from the temperature sensor. I kind of convert that into a temperature here, and then I convert that into an RGB color here. And then I write to each pin the color. The reason it's 1 minus is it's a common cathode RGB LED instead of common anode. So when you set it to 1, it's off, and you set it to 0 and it's on. Weird. But that's why it's 1 minus. And like I mentioned down here, I'm just setting an interval every 10 seconds or longer. I'm resetting the LED, rereading the temperature sensor. The other reason I did this is turns out if you read the temperature sensor a lot, the power makes it warmer, and so you get really weird readings. Like in my hotel room, it went from 72 degrees to 78 degrees in about 5 seconds. I'm like, I don't think that's really the case. But so the other thing I did was I wrote up the example code in BeagleBone IO. So if you've ever done Johnny 5, this is probably going to look a little familiar. So I'm establishing my board, and the only real difference is I'm telling it that I want the I/O to be from BeagleBone IO instead of standard Arduino. Then typical board.onReady function. I've got my 5. I really like the object wrappers from Johnny 5, so it's really nice to be able to say, okay, temperature is a sensor at A1. My RGB LED is at pins 5, 10, and 9. The way you tell what pins they are is there's a pin mappings array. So map the pins, and then basically the vented style temp on data. So when the temperature changes, I want to convert it and set my RGB. Instead of having to do 3 separate calls, I just use the RGB object with an array of colors. So the BeagleBone IO library definitely makes things a little more JavaScripty. That's totally a word. And yeah, so that's my first demonstration. My second one, there's a little bit of background. So I am obsessed with RGB LEDs. I really like making light displays. I really like kind of that creative side of it. And the BeagleBone has a library called LEDscape that's very low level, and it can control up to 48 strips of 255 of these guys, these self-addressable RGB LED strips. Pardon me. And I didn't want to have to write C. Again, I'm a JavaScript addict. So I found out that this particular fork of LEDscape has a socket open at port 7890 that accepts a protocol called the Open Pixel Control Protocol. And so what it accepts are packets that are composed of a 4-byte header and an n-byte package. And it's a channel command, a length with a high byte and a low byte, and then the bytes of message data. So basically you're telling it what pin you're sending the data to, whether you're clearing the strip or setting it, the high byte and the low byte so it knows how much data it's sending, and then the actual data. So what I did was I wrote an NPM module that basically connects to that socket that's running on LEDscape and composes those packets for you. So instead of having to write out bytes, you basically give it an array of pixels, and it will set that strip to that array of pixels. So what I should have done is let this connect while I'm talking, but I haven't yet, so I'm going to let that connect. So one of my coworkers started. That's the port right there. So this is the API for it. You just create a new client. You tell it what address and what port you want to connect to. And then you add a strip with length. In this case, this is all one strip. I just kind of cut it and resoldered it into a grid. It has 25 pixels on it. And I finished this a couple days ago. You can now, before you had to send the entire strip every time you wanted to set it, now you can tell it specific pixels, and it caches the previous frame. So it will it'll insert the new pixel into the frame and resend it for you. But you can set an entire frame as well with the put pixels method. So what I'm going to do is, all right. So right? So the reason I did that, since they're on the same IP, if I try to connect to the second BeagleBone, it'll give me that "you're in a man-in-the-middle attack" message. So I just removed my hosts to allow that to not happen. I'm going to connect to this board and make sure it's running properly. Come on, install drivers. All right, I may have to reboot this guy. So we're going to play it that way. So I found that's one of the other downsides, I guess, I didn't put in the slide. If you're using one board, one BeagleBone board, no problems, super smooth. Using more than one, it gets a little, like I said, I have to remove my known hosts, and sometimes when I connect the second board, it doesn't want to recognize it right away. What's that? Infinite sort of thing. Okay, now it's not showing up at all. Fantastic. Oh, there it goes. Okay. So, no. It's not finding the drivers. Fantastic. I'm going to try the magic mystical thing that switching USB ports sometimes gets it to work because science. Actually, I'm going to go back. I'm going to go over the code while this is attempting to load. So, my node module is a whole 120 lines long, not terribly impressive. Basically, the most of the logic is here, and so it uses a JavaScript typed array because you have to send bytes, and JavaScript doesn't necessarily like sending 255 as a byte. So I kind of learned to package it into a typed array, made it a little easier. As for the demo I'm going to show, this is the first one. Basically, I've got my array of pixels. It's red, green, blue, black, and white, so are off and on. And what it does is every 200 milliseconds, it slices the array and moves it one. So it should basically move each pixel along in an animated string. And okay, it's actually thinking about it this time, so that's progress. And the second demo I'll show illustrates the actual putting one pixel at a time instead of sending a whole new frame each time. And what that'll do is it'll light up each pixel in turn and then turn them back off. So, fantastic. Like I said, live demos, what could possibly go wrong, right? Okay. I'm going to go back to my slides. Hopefully this will wake up and I'll be able to show you, but for now, I'm going to keep going. So that was going to be an awesome GIF, but I hopefully kind of blew your mind with the first demo. Hopefully this will wake up and I'll be able to show you the second one. So what's next for BeagleBone? It's definitely under a very large amount of active development. And one of the major things is they're moving from Angstrom to Debian. I'm very happy about this. Literally the only reason I'm still on Angstrom is because I wanted to get through this talk with stable demos. Look how well that worked out for me. And yeah, so they're moving to Debian. And to me, that means a lot of things. Better serial drivers for one. I wanted to use an Xbox controller with the BeagleBone, and it's like, no, there's no Angstrom drivers for that. And it's like, oh, okay. But there's Debian drivers. Fantastic. A little bit more support for that OS in general as well. So I think it'll lead to more stability on the BeagleBone in general. BeagleBone IO is being actively worked on, so if you're a fan of the nice evented syntax, that's really coming up as a alternative to BoneScript, which I'm very happy about. And I am working on Open Pixel Control actively as my obsession with RGB LEDs continues to get stronger. The takeaways from this talk are that you too can do robotics. If you know JavaScript and you followed along with my electronics lesson, or you can use Google, you can do this too. This is definitely not a crazy difficult thing to do. What I would do is build something. If you've never done robotics at all, I would actually start with Arduino and Johnny 5. But if you've been playing with Arduino and Johnny 5 and you want to take the next step up, I think, or step over even, BeagleBone is a great way to go. And what I want you to do is build something, but don't just do that. Don't just build something and then that's it. document it, please. I have never, ever seen a situation where we have too many tutorials for something or too many walkthroughs of a project. Document what you build, even if it's something really simple. Document it, get it out there, especially if you have like a problem with something. Someone else is going to have that problem. So document not just what went right about your build or what's awesome about it, but the problems that you had to overcome. And excitement is super contagious, I've been told. So be excited, be excited. Talk about your robotics projects. Document them, show them off, and I'm going to see if this works. All right, I'm going to try one more reboot, and then I will give up. All right. Any questions while I'm waiting for this to? Yes.
How does the BeagleBone compare with Esprima and Tessel?
Okay, so Espruino and Tessel run a JavaScript interpreter on the board. So you don't have access to Linux, you don't have access to like the operating system, but they're still very neat platforms. So it's kind of comparing apples to oranges on that one. That being said, I'm working on a JavaScript-enabled dress with an Espruino board, so definitely a fan of those platforms. But it's kind of comparing apples to oranges because they just run a JavaScript interpreter. But they're about the same ease of use in terms of JavaScript, in terms of programming them.
So BeagleBone and Tessel is like Raspberry Pi Arduino?
Yes. To reiterate his question, what are the differences between the Espruino and the Tessel and the BeagleBone? And that was where I said apples to oranges. And then his other question was, so comparing the Espruino to the BeagleBone is like comparing Arduino to Raspberry Pi, and yes it is. It's like comparing those two. So, sorry, allergies. I leave Texas and it's just like, oh, the allergens. So. Also, if you have any other questions, I'm the person with purple hair. I'll be at all the events and things. You can feel free to talk to me. At least I think I'm the only person with purple hair. This has actually happened once where someone else had purple hair and I felt like a dork. So, like I don't know. Fantastic. What time is it? I'm way early. Yep. Okay. I'm going to actually have to pass on that because it doesn't seem to want to boot at all for whatever reason. So, let me back to the slides one last time. Thanks for listening and putting up with the awkward silence as my second demo crashed and burned. I should get this working this afternoon, and I will bring it with me to tomorrow's party with the programmable walls. So if you do want to see it then, I will yell at it until it starts working, and I will show that off tomorrow. That's my Twitter handle and my email address. Feel free to ask me any questions. Again, I'm an engineering evangelist at Retell Me Not. You can definitely ask me what that means at either of the parties. And thank you so much for listening.